All right, here we are. We're starting our hypothesis test section. Man, I hope you're going to watch these videos because it's a little confusing through the example button, or a lot. So I'm preaching to the choir because if you're watching, yay. So watch this all the way through so you get some good examples. We're going to start hypothesis testing, which is just testing about a claim. For example, do we want to test the claim that um, during COVID and during the pandemic that 3% of people passed away from COVID, right? So we would gather some data and we could test that claim of that 3%. What if we want to test the claim that we think we came up with this new app, we've sampled it out there, and we say most people like our app? How are we going to test that? Well, we could do that with a hypothesis test. What if I say I wrote an amazing online course, everyone passes? Well, guess what? I can test that theory. Um, yeah, it's not amazing. It's the best that I can think of. So like you, it's just a matter of that data that you have. So we're going to do this idea of a claim, and we're going to put together what we call a null and an alternative hypothesis, kind of weird wording. And we're going to decide whether something we have enough evidence in favor or against our claim. Okay, so that's where we're headed. Today, we're just going to focus on setting it up because it can be confusing. So I kind of go through in your definitions. What is a hypothesis, right? Hypothesis is just a statement. Okay. And a hypothesis test is we do a full procedure against a claim about something in our big population. So we're testing that claim of that 3% of people died from COVID, or testing the claim that, most people pass my stats class online. Okay, things like that. So I wrote some examples of just some different claims, okay? We can have claims that are greater than, less than, or equal to. Those are our options. And um, the first one's like, you could say something like most users, more than half. So anytime you see most, use 0.5, half. Utilize two-factor authentication. Okay, this one is the mean body temperature of humans is less than 98.6. So less than. We have that mean symbol. We have our P symbol for proportions, right? Proportions are like 20 out of 100. It's like a survey. Or I made 10 shots out of 30 shots when I went to make free throws. Okay, the last one. Population of the college students has an IQ score with a standard deviation equal to 15. So that one we're testing equal with the standard deviation. Okay, we don't use standard deviation on a lot. I mean, it's sprinkled in some of our definitions, but it's a whole nother section that we're not going to cover. So we're just going to cover proportions and means, and it's really just because of time. So um, all right, so when we go to set up this hypothesis, we have two hypotheses. We have our null and our remember our alternative hypothesis. So our null is denoted by like an HO, and it's a statement that is claiming equal to some claimed value. So you have to go through the wordiness of your math problem and find the claim. What is the claim's number? Are they claiming most? So we use 0.5. Are they claiming 82%? I don't know, whatever. Are they claiming 99%? Whatever they're claiming, you need that value for your null. Okay. And when we write our null, we write it as HO dot dot, and we either write a P or a U because we're not going to do the standard deviation one. So, or you could have standard deviation. And we have a couple other ones coming too, I guess. But for this chapter, we're just going to use the means and the proportions. And then you would say equal to this claimed value. Okay, so those are the two ways we will write our null hypothesis. Always equal, always, always, always equal, okay, to whatever value is claimed. 0.5, 0.37, that's some number. This is a number, okay? Now our alternative would be like, what's it saying? Is it saying most, greater than, least, less than, or is it kind of like vague, like, It says a claim of equal, like I say, you know, it's exactly 3% of people died from COVID. That's saying equal. Then I would have to test not equal for our alternative. Okay, so these are the three symbols we'll use in this alternative hypothesis. We don't use equal in our alternative. It's either greater than, less than, or not equal. And not equal is the one that's typically when we don't have a lot of information. So when we set these up, it'll literally be H, A, or capital A, or a 1. And then you will have the symbol, and you will either have this symbol or this symbol, right? And you're either going to have less than, greater than, or not equal to this claimed value. And that's 99% of your homework this time is literally going to be read this problem, tell me the null, tell me the alternative. Okay. So I kind of walk through an example of the null and some examples of the alternative. And I liked this diagram. It really covers 8.2 more, but I kind of liked this idea that we have these regions where we're going to reject or fail to reject this null hypothesis. So where we're going is we have a null, we have an alternative, one or the other, we have evidence in favor. Okay. So that's where this is kind of trying to lead you is like left-tailed would be a less than problem. Right-tailed would be a greater than. A two-tailed would be a not equal. Okay. Let's do some examples. So for problem 1, most adults would erase all of their personal information online if they could. A GFI software surveyed 600 randomly selected adults, and they showed that 59% of them would erase all of their personal information. State the null and alternative. Okay, so first of all, we know we want to label HO for our null, and we want to label HA for our alternative. Looking at this problem, am I saying so many out of so many, or a percent of people, or am I giving a mean? We are given a percent or so many out of so many. So 59% of 600 is literally the information we're given. So that means we are doing a proportion, right? It's a proportion, a certain percent or straightforward. Like I'd have to figure out 59% of 600. And it says, okay, of them would erase, a select showed that 59% of them would erase all their personal fight. Okay, so when I say most adults, that's what I'm going to claim. So the 59% is the statistic. It's the information given about the sample. You have to decide, what am I actually claiming, because that value goes on your null and your alternative. So for this one, it's going to equal 50% because it said most adults. This is about the stats. This is a statistic that we would use for the full hypothesis test, which we're not going to do yet. So then we have to show, does this one state would erase, so just show that 59% would erase all of their personal information. So I have an equal, I don't see any, excuse me, not equal in there. I mean, sorry, no wording about greater than, no wording about less than. So what would we go ahead and put on this one? We would put just not equal. 0.5, because it's vague. It's not telling us greater. It says most adults would erase their personal information if they could. Most adults. I almost want to say greater than, but I don't like. I want to. Most adults would erase it. I don't see. There's no greater than words, so my brain goes greater just because would erase all of their personal information. Okay, so for problem 2, fewer than 95% of adults have a cell phone. That's funny. have a cell phone? I think it said um, fewer than 95% have a cell phone. That is so bad statistics. I think it meant to say like a smart cell phone and it was older information. Oh well, we're gonna go with it. I'm like, this is not exactly what I meant to have in there, but that's okay. Fewer than 95% of adults have a cell phone. In this poll of 1,159 people, 87 people said they have a cell phone. State the null and alternative. Like 90 million people, everyone has a cell phone now. So this seems silly, but okay. So we're still going to do the same way. HOHA dot, 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 dot. Now, again, we were told 87%. We have so many. This is a proportion. We weren't given a mean. We weren't given an average. So again, a proportion, you better always just automatically write equal on your null. What is the value we are using in our claim? Our claim is fewer than this many. So our claim is against the 95%. Always write it as a decimal. It's what we do. Percents become a decimal. Okay, so fewer than 95% is the claim. I'm going to label this claim right here. I'm going to also probably label this the claim, and that will help with that next class or that next section. Knowing which one's your claim. Our claim, well, oh, that's not our claim on this one. I lied. It was on the other one. This next one will be our claim. It will help in the next step if I write it on the right one. So what is our next one? It says fewer than 95%. So we need to write fewer than 95%. So typically the claim is the alternative hypothesis, but it could not be like problem one. Okay, so equal and not equal are usually the equal is the claim. And so the other ones, the claim is typically the greater than or the less than. So this is how I set up something that's fewer than 95% of the adults have. I really should say greater. Oh, well, you get the point. Okay, for problem 3, the mean pulse rate of adult males is equal to 69 BPMs. For a random sample of 153 adults, the male's mean rate was this and their standard deviation is this. So now I'm given very different information. I'm given a mean and a standard deviation because you need the standard deviation to do the test. So this one, when I set up these tests, what symbol do I want to use if it's about a mean? I want to use that population's mean symbol, always equal here. And then for this one, I want to say, the mean pulse rate of adults is equal to 69. So the claim is right here. This is our claim. So this is our claim. So we would then have not equal to 69 is going to be your alternative, because if we have equal, then the only other option is not equal. It's a two-tailed test. I don't know which way I go. Okay, and fix this to be not equal here. It doesn't say greater on that first question. I did pause it and think about it for a second. It doesn't say greater. So I'm trying to not make any of these super tricky. They really should say greater and less than or fewer or, or equal. So those are our nulls, right? Our nulls are either equal. Well, our null is always equal, excuse me. Our alternative is the three options, either not equal, if your claim was equal, not equal, and then greater than or less than. They better say the claim is more people have a cell phone or something like that. Okay, I have a couple more questions. A friend is tested to see whether he can tell bottled water from tap water. There are 90 trials, half with bottled water and half with tap water. And he gets 54 right. So we're testing to see whether he can tell the difference between this much and this, the two waters. There are 90 trials. So our null is going to be our HO dot dot. Again, we have a proportion, 54, he's saying out of 90 or something like that. So P equals, what is our claim? Our friend is tested to see if he can tell there are 90 trials and he gets 54 right. Our claim is he can tell the difference between the two, so he should be getting at least half of them right. So I'll use 1/2. Um, oh, I paused it because I was sneezing and then I push unpause and I sneeze again. Okay, so our alternative on this one, what is the claim that he can tell the difference? We would want more than half for his claim is more than 1/2 because he's saying he can tell the difference. So he should be able to do more than half of them. I don't know if I love, oops, this should be down here. I don't know if I love that problem. I think it's a little crappy. This is the first time I've done these questions. I just stole them out of the textbook or somewhere. I don't even remember where I stole them. That one's not my favorite. Okay, a new medicine is being tested to see whether it can reduce the chance of lung cancer in people who have been habitual cigarette smokers, or should we say vapors. The rate of lung cancer in the population of concern is 31% or 0.31. The null hypothesis is that the population proportion use, and then what's the correct? Okay, so it gives us the null. It says the population proportion using the new medicine is equal to this. What is the alternative? So let's write it all out in our symbols. So again, it's a proportion because we're given 31% or 0.31, or never does it say mean or standard deviation. So we'll use the P and it equals 0.31. And that's our new medicine is going to go against that. Okay, so what would be the alternative? They already told us this one. If we want it to reduce the number, what symbol should we use for reduce? Less than 0.31, right? And this is our claim here. So we would like less than 31%. So if right now there's 31% of people getting cancer, lung cancer from smoking, then we would like this medication to reduce that. Okay. All right. And they're always coming out with new medications for cancer. Okay. It's kind of, I always want to look at the cancer statistics because it's so strong in my family. I've even already had it too. So, question 3, claim the mean pulse rate in beats per minute of adult males is equal to 69.8. Didn't we already do whatever? The random sample of 181 adult males, the mean pulse rate and the standard deviation are as follows. So the claim is that it's equal to the 69. So our null will be mean is equal to 69.8. Pretty sure we use the same one above. That's okay. And then our alternative, if we have equal, better be not equal to 69.8. Okay. So what you're going to do is read through, and every null better be equal. And then your alternative better be not equal, less, or greater, depending on the claim. Okay. So you are having to set this up with the claim. You have statistic information in every problem. Okay. We are doing the full test, so we're not using that. So you need to decide what's a statistic and what is part of the claim in each problem. And that's all you're doing for this homework. Okay, let me know if you have any questions.